Namaste. Today, I want to talk to you about one fundamental question that usually people in AI ask. We often hear that I'm using AI technique for this problem, or I'm applying AI here, and those kind of things. What kind of problems do you need to apply artificial intelligence to solve? So if you look at it from a software point of view, that is, you are building application programs, there are many programs that we have written, through using C, Pascal, Java, and all that, and many applications, e-commerce applications, e-governance applications, e-learning applications, learning management systems, and so on, so on. All of these, we know how to do it well, and we know how to write the code, we know how to structure it, and we are not expecting any major intelligence in its behavior or in actions. Mostly, like for example, you fill up a form and you submit it, it should get stored in the database. There is no big questions there, how it should be stored, what it should be done, and all. So we say that these are kind of algorithmic solutions. That is, there are clean step-by-step procedures where every step is very clear, very precisely executable by a human being or by the computer. And those kind of problems is what traditionally we used to write computer programs for or build computer applications for. But there is a whole lot of category of problems where um, some of these characteristics are violated. So, for example, many domains have the data or the information available is uncertain. For again, for various reasons, that's uncertainty reasoning itself is a big topic. We'll maybe look at it later on. So, for example, if I ask a patient, do you have pain? The response can be very different depending on whom I am asking. For the same kind of pain, somebody might be screaming their head off. Somebody might be saying, "Yeah, I have some pain." So, how does a doctor know what is the degree of pain or how bad the pain is, and if the response can be so varied? Okay, and similarly, you ask what is the weather like outside, or how old is that person, or whatever. Many of these questions, the answer is not very precise. Unlike, for example, what is the weight of this item, you can put a weighing scale and get exactly 2.53 kilos or whatever, right? So uncertainty is one of the things that is very integral to human activity. Most of the tasks that we do day to day and even major decision making, whether to buy a company, whether to sell a share here, or to when in diagnosing a disease, or in recruiting a candidate, or in whatever, all of these decisions are plagued with uncertain information, but we still need to take a decision. Similar kind of a characteristic is incompleteness. Again, in many decision-making tasks, we do not have the complete information available to us at the point of taking decision. So we still need to take decision and maybe take corrective measures as we go along, but sometimes even that may not be possible. Another characteristic that kind of is integral to our day-to-day activities or decision-making activities is, as we are doing the thinking or the planning, working out a solution, the world outside is not staying constant. Okay, so as we explore the various options, so when you normally do a computer program, you assume that the input is there and it is waiting for you to take a decision. Until that point, the input remains. That is not true in many of the situations. So, for example, when I am planning to go from A to B, as I am planning, the situation in A or in B or even in between may actually be undergoing changes, right? So the world is dynamic and we need to take note of it as we do the implementation. So uncertainty is a key element, incompleteness is an element. There is also what is called non-monotonicity. So as of now, I am told that this person is like this, or he has this characteristic. But maybe a little sometime later, somebody will come and sorry, that's actually not correct. No, this is actually the correct answer. Or we may think that the price is going to increase, but little later we find out that the price is actually reducing. So non-monotonicity is we are required to believe some information at this point, but as we go into the implementation or we decide discussing the further steps, that fact itself will change. So when we usually on software and all that, when you say a fact, that is something that doesn't change. So the cost of this is this, the cost of that is that. But in these situations, we find that this information may change with the time. Okay, and we are forced to revise the assumption. So you have certain information and you decide to take somebody or to promote somebody, and then little later you get additional information which actually kind of questions your decision. So you may, if it is possible, you may go and undo that decision. But sometimes if the decision has already been taken and implemented, you will need to see how to react to that additional information. So non-monotonicity is one of the components. Yet another fact that we usually deal with is what is called belief systems, okay, or belief worlds. So I have certain beliefs about the whole world at this point in time. I mean, so that includes the belief about what the people around me are, my understanding or my feel of how they would react to something, and how my family will react to something, how my family is, what their thought processes are. All of these are currently my belief. It is only in my head. But and my family or the other person may also have a belief about me and all these other people, which is that person's belief. So a particular information, for example, is this fact true? Okay, that in my belief it may be true, in somebody else's belief it may be false, and maybe the actual reality may be something else also. So we are comfortable in dealing with these multiple belief systems, right? I believe that, you believe that, he does something, etc., right? So you can have these worlds where one piece of information might have multiple values depending on which belief world that you are looking at it. So these all causes problems in modeling a solution of this problem of this nature, or a problems which has this characteristic. Building a solution is much harder. The traditional software development and all that actually doesn't work here. That is where you look at and say, okay, how does a human being deal with it? I mean, how does a doctor make a diagnosis and prescribe medicines when there is incompleteness, there is uncertainty, and all of that? These factors are there. And when somebody, a company head is deciding to acquire a company or to sell off a company, similar issues arise. There are a lot of information which may not be available, which may get instantiated later on in the way consistent with his existing belief or inconsistent with it. But you still have to make a decision, so you take decision and then you see what best you can adjust to that. So these are the characteristics that makes it worthwhile looking at whether I should use an AI technique, because we human beings somehow seems to be very comfortable dealing with these kind of properties, or these characteristics or problems. Almost everything that you do, from the time you get up in the morning to going to office, to making something to eat, or going to the canteen to pick up something to eat, every step you can see these properties are inherent everywhere. You don't know exactly what you will get in the canteen at this time, whether that will be still in stock, whether that is ready to eat. All of these are, so this uncertainty, incompleteness are inherent to our decision making task, and that is what we are attributing that, okay, this is why we say we are applying intelligence. Okay, so when a problem has these kind of characteristics, we say, okay, it could be something that we can look at whether AI techniques are useful. Okay. So, but doesn't mean that problems with these characteristics are solvable with AI. There are problems which are possibly too complicated, too difficult to do. That is the unsolvable category. And then with AI techniques and all that, you are able to get something. So, in the next piece, I'll talk about what does it mean to say that I'm using an AI technique to solve a problem? What kind of information do I do? What kind of approaches do I take? Um, how do I make these apparently unsolvable problems solvable using these kind of mechanisms? Okay, so that's the topic for the next session. So till then, take care.